So now moving ahead with the next part of our solutions of the paper 1. See, we solved till question number 13 in the previous video. So now moving from question 14 till 25. See, I will again repeat that the paper which we uploaded, the solutions whose solutions we are discussing, whose solution we discussed in the last video, I will keep that paper as a moderate paper, neither easy nor tough. Okay. Now, as you all must have observed, you have been told that the initial shifts are going to be easier one. That's what we have analyzed also, bacho. That's what we have observed also from last 4-5 years. So, I'll be solving easier paper. I mean the paper which will be meant for the shift like first 3-4 shifts, particularly first 2-3 shifts. Okay. In the next one, and then the tougher one at the last, because we expect the tougher question, the tougher paper near the end of the JEE mains examination. Okay, so chaliye, so continue. So that's the question. I hope several of you would have been able to solve it. So now how to approach it? So for that I will say, see, in integral, the most in indefinite integral, the most important method for me is method of substitution. So what we try here is, we try that if we replace a function by a variable t, then we should get its derivative sitting with dx so as to replace it with dt. So that's the entire focus is. So here, as I can see, if I take x raised power 4 out of it, bacho, let me try. So it's x square, what is it, x square minus 1 in numerator, and then in denominator we have x cube. So I said if I take x raised power 4 common from square root, it will be x square out of it. So we'll be left with 2 minus 2 by x square plus 1 by x raised power 4. Now let's see what do we get. Okay, so what am I expecting here is that we get, when we take x raised power 5 in the numerator, we will get 1 by x cube minus 1 by x raised power 5. Now what we have to check is, do we have this as a derivative of this thing? So of course now you all know that what are we going to do? We are going to replace this by t, isn't that bacho? So if I replace this by t, let's have its derivative. So dt will be, it will be 4 by x raised power 4 minus 4 by x raised power 5. So if you take common this, we get rather 4 by x cube here. So 1 by x cube minus 1 by x raised power 5 dx, and that's what we have exactly here, bacho. Okay, so that's simple now. So integral is nothing but 1 by 4 dt over root t, and then you have it. Okay, so 1 by 4 t raised power minus half dt, and then we know integral of t raised power n is t raised power n plus 1 upon n plus 1. So it's simply like 1 by 2 root t, isn't that? So 2 plus whatever, see whatever we have as t. Okay, 2 minus rather 2 by x square plus 1 by x raised power 4. If you wish, you can take LCM and then we get it. Okay, so which one? Maybe the C1. C should be the correct option in that case. Yes. So moving to the next one, bacho, the value of this integral. So again, that's a question of integration, a definite integration question. See, you can approach it in two ways. So if we use the basic definition which says that x is nothing but greatest integer of x plus fractional part of x. So therefore, I can write my integral 0 to 10, and that is 3 raised to the power greatest integer of x plus fractional part of x over 3 raised to the power greatest integer of x. So what do we get ultimately here? So we will get here, of course, using a rule of exponent, we can write it as 3 raised to the power greatest integer x into 3 raised to the power fractional part of x. Greatest integer part gets cancelled here, 3 raised to the power fractional part of x. Okay, now see, we know that fractional part of x is a periodic function. So it's a periodic function whose fundamental period, so fractional part of x is a periodic function whose fundamental period is with fundamental period as 1, and from the property of integral which says if t is a period of a function f of x and we have to integrate it where n is an integer, then we can write it as n times 0 to t f of x dx. So using that property, we can write I as 0 to 10, which is 10 into the fundamental period of the function, which is 1 here, 3 raised to the power fractional part of x. Achha, one more thing. Few of you might be thinking that, okay, fractional part of x is a periodic function, but what about 3 raised to the power fractional part of x? Now here again, we'll be using that property which says if I put a periodic function within non-periodic function. So n is a non-periodic function whereas capital P represents the periodic function. So then the property says that it's always a periodic function It's always a periodic function with the fundamental period of this periodic function being a period of this function. Okay, so from that logic, from that reasoning, we can say that 3 raised power fractional part x is a periodic function with 1 as its period here, or fundamental period. यहाँ पे कोई ज़्यादा difference नहीं होगा. So 10 times. So using this property here, using this property, we can write 0 to 1, 3 raised to the power fractional part of x dx. Okay, now see again. Fractional part of x, that's very important bachcho, x minus greatest integer of x. Okay, so when x belongs to 0 to 1, open or close doesn't matter here, I mean for 0. Okay, so it's x minus, so from x, when x is between 0 to 1, greatest integer part is 0, so it's x minus 0. So hence fractional part of x can be replaced by x when x lie in the interval 0 to 1. So now we are done. So 10 times 0 to 1, 3 raised to the power x dx. And then we have its integral, and what is it? So integral of a raised to the power x is nothing but a raised power x by ln 3. And then it goes from 0 to 1. So 3 raised power 1 is 3 minus 1, which is 2. So 20 over ln 3 should be the answer. So that's the answer here. The second approach could have been, if someone couldn't relate it with periodic function and all those properties, then what you can go for is, see, then the simplest basic kids method, I will say, is that go ahead by opening the greatest integer function. So greatest integer function is 0 when x lie between 0 to 1, so you just need to break it, and this is 1 when x lie between 1 to 2, and then it is 2 when x lie between 2 to 3, and so on and so on. So I can write this integral as 0 to 1, 3 raised power x dx, 1 to 2, 3 raised power x by 3 minus 1 dx, plus 2 to 3, 3 raised power x by 3 square, because you will be replacing greatest integer of x by 2, so it's 3 raised power x minus 2 dx, and then you solve it, you get the same thing again and again, and that's it. Okay, the same thing you will get again and again, which you get for here, or you just solve it and you match the answer. Okay, so I call it a kids method, just discuss it, but of course the method which all of you will prefer to use or would have used, I believe, is this one, isn't that? So that's next. Moving to the next one. Next question is this one. Consider the area found bounded by the curve fx is equal to e raised power minus x plus 3 and g of x is equal to ln of x plus 2 when x lie between, or x is and the curve or the line x is equal to minus 1 and the y-axis. The areas divided by the line passing through the points of intersection of these curves with the coordinate axis are in the ratio. So first let us draw these curves. Okay, so first one, e raised power minus x plus 3. Now the curve of e raised power x is this one, isn't that? Okay, we all know it. So how will we draw the curve of e raised power minus x? By taking its mirror image, the mirror image of the entire curve on the y-axis. So the curve of e raised power minus x will be something like this. Okay, so if I erase this, that's gone. Now plus 3. Plus 3 means, so we have to shift the curve 3 units upwards. So we shift it 3 units. So this point is 0, 1. So we shift it 3 units upwards, and that's the asymptote which also got shifted. So this is y equal to 0, the x-axis asymptote. Now this is nothing but y is equal to 3 here, and this point is nothing but 0, 4 here. So in white we have the curve of y is equal to e raised power minus x plus 3. So I am removing here the other curves. Okay, now let us go with the curve of which one? Ln of x plus 2. So what's the curve of ln x? Ln x curve is something like this. So when you add a constant within the input of the function, the curve gets shifted by that many units towards left. Okay, horizontally towards left. So this point will come here, minus 1, 0, and the asymptote, which was x is equal to 0, will get shifted by 2 units towards left. So the curves will be something like this, and then at what point will it intersect the ln2, the y-axis? It's ln2, so somewhere here maybe. That's the curve. Okay, so again I am removing this ln x curve here. So in yellow we have the curve of y is equal to ln of x plus 2. Okay, now x is equal to minus 1 line. X is equal to minus 1 line is interestingly passing through this point where the log curve means the x-axis. So that's better for us. and the y-axis. So that's our y-axis. So which area is the bounded, which region is the bounded region? That's the bounded region here. So if we get its area, so therefore area of the shaded region is this curve minus this curve. Okay, above curve minus below curve between -1 to 0. So limit of x goes from -1 to 0 because the bound of the region starts from the one bound is from is at -1, another bound is at x is equal to 0. So the boundaries are from -1 to 0. Upper curve, which is e raised power minus x plus 3, minus lower curve, which is ln of x plus 2, and that's it, dx. So we can easily solve it. Okay, now this actually the question is the areas divided by the line passing through the points of intersection of these curves with the coordinate axis. Now look at here, we will find that no curve intersect both the axes. The first curve, exponential curve, is intersecting the exponential curve doesn't intersect both the axes. Log curve is intersecting both the axes. Okay, the line joining, so of course that's the only point where exponential curve intersect the y-axis. Now the line joining could be this, but then that don't divide it in any ratio. You have the entire region on its left. So logically also you will be drawing this as the line joining this and this. So -1, 0 and 0, 4. So we can always have this equation of the line. And then what? So of course if I say that this area is, let's say, A1 and this area is A2, we can easily find the area, any one of those two area, maybe A2 here because the line minus the curve or the log curve. Now how to get this equation? Of course we can use 2-point form. So it's y minus 0 and then x1 y1 ho gaya, so y2 4 by and then 1 and x minus plus 1, isn't that bachcho? So the equation of line is y is equal to 4x plus 4, isn't that? Okay, so y is equal to 4x plus 4. So now see, if we have to get area A1 here, so again the bounds are same, -1 to 0, the above one curve which is a straight line, 4x plus 4, so it's 4x plus 4 minus the log 1 ln x plus 2, and then that's it, dx. So just simplify it, and then see, we need the ratio A2 by A1 or A1 by A2, whichever matches with your option. So a bit lengthy calculation might be involved, so that's why I'm not completing it, but that's the method, that's the reason, and that's the steps which we will be following normally. Okay, so that's my suggestion for this question. That's how we can approach it. So of course you can complete it and match it with your option. The answer one is the correct answer is the C1. Now moving to the next question. The next question is differential equation dy by dx. So it's dy by dx. I bring it that side, so to convert it to the what, bacho? To convert it to the linear differential equation. Now what is linear differential equation in dy by dx form? It is p of x into y is equal to q of x here. Okay, so that's the linear LDE form here. So p of x, so we know we will be going for integrating factor, which is e raised to the power integral of p of x dx. So what's the integrating factor? Which is 1 by x integral dx, which is ln x. So hence x is the integrating factor. E raised to the power ln x is always x, bacho. Multiply both the side by integrating factor, we get x dy by dx plus y is equal to, I think, minus sin x, and then we know when we integrate it, see, the beauty of integrating factor is when you multiply the LHS by integrating factor and then you integrate, in LHS it's fixed what are we going to get. So in LHS what are we going to get? We are going always get the dependent variable, which is y here, into integrating factor, and then of course we'll be integrating the RHS, which is minus sin x dx. So what is it? So xy is equal to, it's cos x, integral of sin is minus cos, so minus sin is cos, and plus c of course. So how to get value of c? I believe they would have given, yeah, y of 0 is 1 here. So let's use it. So y of 0, that means when x is 0, y is 1. So when x is 0, so 0 and this is 1 plus c, so c is minus 1 here. So therefore, that's it, bacho, that's it. Now that's it. Now see, the question is which among these points does not pass through it. So let's satisfy. If I put x is equal to pi here, so it's pi, and then that is cos pi is -2. Okay, so nah, that won't satisfy. If I go for this pi by 2, so pi by 2, so x is pi by 2. Wait for a minute. -2 by pi seems to be satisfying. No, bacho. Just let's try. X, put x pi, y is equal to -2, so y is -2 by pi. Oh, that's fine. Okay, pi by 2 and -2 by, so when it is pi by 2, y, and cos pi by 2 is -1, so y is -2 by pi. ये भी ठीक ही है. Minus pi by 2 and 2 by pi. So minus pi by 2 y, and this is -1, y is 2 by pi. All seems to be satisfying it, bachcho. So let's see, the D1 should be the answer. It's okay. D1 was the correct one. Now let's move to this question. See, that's a very standard question, but still deliberately I selected it as a part of the test because it involves few things which might be important. I mean, when a paper goes on the tougher side, a line through A -5, -4 meets the line. So that's a standard format question. When we talk about the application of parametric form of a straight line. Okay, so in the chapter of straight line, if we are going for application of its parametric form, so these type of questions are the standard question form of the question. So let's try to solve it. To be true, I didn't solve it because just by looking at it I realized it has to be in that form. Okay, parametric form. So that's why I just put it in the paper. So a line passing through this meet these three lines. So okay, so let's draw these three lines randomly. So let's say these are the three lines. So this is L1, L2, L3. Okay, so we have to be careful to use it. So L1 is x plus 3y. So I'm writing it here, x plus 3y plus 2 equal to 0. That's our line L1. L2 is 2x plus y plus 4. So L2 is 2x plus y plus 4 equal to 0, and the third line here is x minus y minus 5 equal to 0. So these are three lines. Now there's a line, a variable line passing through the point A -5 comma -4 here. So let's say that's the point -5 comma -4, a line that intersect all of them. The points B, C, D respectively. So B is for L1, C for L2. So B for L1. Okay, we got an order. No, that's really good. Okay, the reverse order though, B, C, D. Nice. Now what do we need? Okay, so we need here 15 by AB, AC, AD. Now see, that's what I always say, that if anyone has to recognize that when or where or how will we come to know that we have to apply the parametric form of equation of line. The biggest hint lie in the statement of the question, which says, if it says that we need distance along a line from a fixed point. Okay, now look at the expression here, AB, AC and AD. Now aren't these three the distances, the different distances along the same line from the same fixed point? So again I am repeating, if we need distance along a line from a given fixed point, we will go for parametric form of equation of line passing through that point. And to write the parametric form of equation of line, what we actually need is just that fixed point through which it passes. So the parametric form will be x minus x1 by cos theta. Since the slope is not given, so that means there can be infinite many such line which follow this, and R is the parameter. And what is R? R is actually, so if that's the line passing to the fixed point A, which is -5 comma -4, then R is the distance of any variable point Px comma y from this given point along that line, bachcho. Okay, so see, so that means I can write our point P, any point on the line, in terms of theta. So what is it? So if I solve this with R, we get x, which is, so x is nothing but R cos theta minus 5, and y is R sin theta minus 4. I think all of you will agree with that, bachcho. Okay, so that's the coordinates of any variable point on the line, isn't that? Now see, what are we given? We are given in this question is 15 by AB. So AB, let us like, of course, for different values of R, we will get different point on that line B, C, D. So AB, so I will say R1 whole square plus 10 for AC. I will use R2. The distance of point C from point A is R2. So AC is R2 whole square, and 6 AD is R3 whole square. But importantly for R1, so let point B be. So B point I used in place of R1. So this is R1 cos theta minus 5, R1 sin theta minus 4. Similarly for this point C, I am using R2, so it's R2 cos theta minus 5 and R2 sin theta minus 4, bachcho. And for this point D, it's R3 cos theta minus 5 and R3 sin theta minus 4. Okay, now since B lie on this line, it's a point of intersection with the line L1, so it must satisfy it. Just put it here. So if I satisfy here, so it's R1 cos theta plus 3R1 sin theta, okay, and then minus 5 minus 12 is minus 17, plus 2 is minus 15, and see, you got 15 here. Okay, that's interesting. Now take R1 common and take it, bring it down to 15 by R1 is nothing but cos theta plus 3 sin theta. That's the first value we got. Now I believe you all would have the idea what next are we going to. We will following the same pattern. C is a point on this line, will satisfy it. So it's 2R2 cos theta plus R2 sin theta, and then it's minus 10 minus 4 is 10, so it's 10 here. So therefore from here we can write that 10 by R2 is 2 cos theta plus sin theta, just sin theta, isn't that the truth? Okay, so we got it. Similarly we should get for D also. So D, that lie on X, there's a third line, yeah, here it is. So R3 cos theta minus R3 sin theta, and then it is minus 5 plus 4 minus 5, so it's 6. So do we have 6 here? We have 6 here, right? So we have 6 here. So 6 by R3 is equal to cos theta minus sin theta. Now put these values, this one, and that one. Okay, on both the sides we'll get a relation between sin theta and cos theta. Okay, and then see, once we get theta, we get slope of that line, and hence the answer. So let's do it quickly. So if I just use it here itself, so 15 by R1, 15 by R1 is cos theta plus 3 sin theta, so it's cos theta plus 3 sin theta whole square. 10 by R2, where it is at here. 10 by R2 is 2 cos theta plus sin theta, so 2 cos theta plus sin theta whole square is equal to 6 by R3, and how much is it? 6 by R3 is cos theta minus sin theta. So if I wish I am not wrong anywhere in any calculation, otherwise it may, I mean we might be in trouble. So 4 cos square theta gone, so 4 cos square theta. 9 sin square theta gone, 9 sin square theta. And then this is minus 2 cos theta plus 6 sin theta cos theta plus 4 minus 2. So minus plus 12 sin theta cos theta equal to 0. So did we get it? So 2 cos theta, yeah, we got it. 3 sin theta whole square equal to 0. And then we have it, and tan theta is nothing but minus 2 by 3. That's it, bachcho. Slope is minus 2 by 3 and passing through. So slope is minus 2 by 3 and passing through the point minus 5 comma minus 4. You can have that equation. So which one satisfied it? Basically minus 5 minus 4. Yeah, D one should be the answer. So that's it. So that was a good question actually, based on the application of parametric form of equation of straight line, and that's why I selected this question, bachcho. So that was the purpose. So we are done. So D1 should be the correct answer. That's it. Now that's a simple question, range of this trigonometric function. So we all know it. So what are we going to do? We will convert it to perfect square form, sin square x plus cos square x, because that's fixed, whole square, and then to balance it 2 sin square x cos square x, isn't that? Plus 2, so it's 1 minus half and sine 2x whole square. So I'm doing it quickly because I don't think any one of you will get stuck here. Okay, 2 sin x cos x is sine 2x, so multiply and divide, so you get 2 sin x cos x whole square, and that's it. So range, of course, when you put its maximum value, we get its minimum value. Okay, and no, there's no 3 by 2, it's just 3, isn't it? So 3 minus half is one thing, and then 3, of course, when sin x 2x is 0. Okay, so it's 3, so answer is 3 minus half. How much is it? 3 minus half should be 5 by 2 to 3. So no such answer, isn't that? So is there any mistake here? I don't think so. Just a minute, bachcho. Yeah, none of these should be the answer, isn't that? 3 minus half is 5 by 2. 5 by 2 to 3. Yeah, there is a mistake here. It's not 3 by 2, isn't that? Chaliye, we'll move ahead. Okay, now see, the purpose of this question was just to share with you the few things, the few results, few observations related to the questions on the variance and mean from statistics. So these are n observations, and let x be their arithmetic mean and sigma square be their variance. Okay, with observations like then the variance of the data with observation like this. So okay, first of all, when you shift, when you add or subtract a constant to all the observation, the mean will also get like shifted by that much point. Okay, so if someone would have asked you to find the new mean means when the observation would have been like without 5, x1 minus 4, for x1 minus 4, x2 minus 4, x3 minus 4, dot dot dot. When the observation is like that, so new mean is same as the old mean, the old mean minus 4. Okay, so the mean will also get shifted by that much unit. Okay, that's one thing. But when it comes to variance, for this case, the old variance and the new variance will be same. Be very clear about it. So by shifting the entire data by same unit, there won't be any difference in the variance of the data. Okay, the variance of data get disturbed or by when you multiply or divide all the data by same unit. Okay, so when you are multiplying all data by 5, this is the only factor which will disturb the variance, and by how much points? So it will be square. Okay, so new variance in that case will be 5 square into old variance, and that's the question here. Okay, and the logic is clear, because see, variance is all about the deviation. Okay, so deviation, there won't be, when the entire data is shifted, there won't be any change in the deviation as far as the old data and new data are concerned. But of course, when data is multiplied, the deviation will also get multiplied by that much, and variance involves summation of xi square, hence it will be 5 square or 25. Okay, so keep these observations or these results in your mind, so that if you come across any such question, you can get the answer quickly. Just by going through the statement or looking at the option, you know what the answer is. So the answer is A here. So that's it. So the purpose was only this much, to discuss these few small points from statistics. Okay. Now let's move to the next question, 21st question, TEJAS type. So if vector A, vector B and vector C be 3 non-zero vectors, no 2 of which are collinear. Okay, now if vector A plus 2B is collinear with C, so what does that mean? So that simply means I can write this as lambda times C. And vector B plus 3C is collinear with A, so B plus 3C is collinear with A, so I can write it as some scalar P times vector A. Okay, then we need the magnitude of vector A plus 2B plus 6C, that's what we need here, bacho. So see I believe it's a simple question, isn't that, bacho? Most of you would have been able to solve it. See, what I will do here is C. Okay, so let me just write it here. Instead of lambda C, I could have written this as lambda, isn't that? If A plus 2B and vector C are collinear, so either you can write one as scalar times other, so that's your choice. So since I am thinking to put the value of vector C from the first relation, so that's why I defined, or I use this at that vector C is lambda times A plus 2B, put this there. So 3 times, or rather 3 lambda times vector A plus vector 2b, and this is p times vector A. Now see, they have said that no two of which are collinear. That means vector A and vector B are non-collinear, and two non-collinear vectors are independent vectors. Okay, so when, see, you should know, when we linearly combine two independent vectors to write it as a null vector, then that is possible only when the involved scalars are 0. What I want to say here is, if I collect the scalars for vector B, it's 6 lambda, and then for vector A, it's 3 lambda minus p is equal to null vector. And since vector A and vector B are non-collinear, hence they have to be independent. As I said, if you combine two, linearly combine, what does that mean? Multiply the vector by scalars and add them. So if you combine two, linearly combine two independent vectors to write it as a null vector, now that's possible only when both the scalars are 0. So from here you get lambda as minus 1 by 6 and p as half, I think. Okay, so a plus 2b. Okay, we got it. We don't need p actually. Okay, so vector C is minus 1 by 6 times vector A plus 2 times vector B, bacho. And then you just put the value here. So 6 times vector C is minus A minus 2b. And then when you add it, so the answer should be 0. I think that's what you all would have got. So that's it. So that was question number 21. Now moving to question number 22. Let theta be the angle between the lines. So we have written the, already see, the line is given as a parametric form here. How? So you can write x minus 1 by 2 is equal to t, which is y minus 1 by minus 1 is equal to z minus 1 by 3. Isn't that? So that's the line. That's the line. Similarly, you can write for this one. So see, if you observe, see, we need angle between the lines because that's theta which you are going to use here. So here, if you observe, so these coefficients are the actually the dr. So a1 comma b1 comma c1. The direction ratios of the first line are 2 minus 1 3 and a2 comma b2 comma c2. The drs of the second line is 3 6 and then 0 times s here. So let's find angle. So cos theta, so how much is it? Cos theta is a1 a2 a1 a2 6 0. That's good. Theta is pi by 2. Now the value of this is k, and we have to find this value. So k is 0 to pi by 2. Now what else? So that's a good question in that case. I mean, is even, but involves few concepts here. So they have connected the 3D dimension geometry, angle between the line thing, and then angle, and then a definite integral. See, if you convert it to sine and cos, what will you get? Cos x over sine x plus cos x. Now using Bahubali property. So what is it? So Bahubali property. So I say fx dx integral a to b is a to b integral f of a, very important property for definite integral, bacho. So using this, so we get I is equal to 0 to pi by 2. Of course the cos will get it's pi by 2. Cos will get converted to sine x here. Why? Because pi x has to be replaced by pi by 2 minus x. So it's sine x upon, so it's simply sine x upon sine x plus cos x here, and that's it, dx. So now adding it, see, that's what I always say. When you are using Bahubali property, most of the times you should know that we are going to add the integral which we have and the integral which we get after applying the property. So 2i, and once you integrate, since we have same denominator in both of them, so that remains same. So of course we don't have to take any LCM type of thing here, and numerator gets added directly, and that's it. So that's it. So this one, so it's pi by 2. So hence I is pi by 4, which is actually k here. Okay. So 596 pi into pi by 4. So 150. So 149. No, that's it. That's it. Okay. So that was a beautiful question. A simple question, but involved few different concepts here. Now matrix A is given. So determinant of A, matrix A is 6, and adjoint of A is, okay, see, a simple direct property, determinant of A is 6, and then determinant of adjoint of A, what is it formula, bacho? So it's determinant of A raised power n minus 1, where n is the order of square matrix. So here it will be 6 square, 3 minus 1 is 3 cross 3 over matrix. So now, so we have to just write this determinant of adjoint A, which is 1 minus P. So it's minus P plus 2 times 4 plus 1, I think, yeah, plus 1 here, plus 4 times 4P plus 1 here, which is 36. Okay, just a minute. So 14, 16, 15P plus 6, okay, 4 to 30, yeah, we got it. So that's simple, no? A simple question here, bachcho. So P is equal to 2, yeah. Now moving to the 24th question, the second last question of the test paper. Fx is this and fx is that. So fx is defined on the left side of 2, the function is this, on the right side of 2 is this, where a is a positive constant. Okay, if fx has local minimum or a minima at x is equal to 2, then the least integral value of a is c. Whenever I have to approach this question, I always approach it with the help of figure or a curve here. So for x greater than equal to 2, it's something which is direct here. So this is 2 here. Okay, so for x greater than equal to 2, it's a straight line 2x minus 3 whose value is 1 at 2. Okay, and of course its slope is positive, so it starts from here, close here, and that's it. Okay, so let me just draw it like this. So that's it. So that is equal, y is equal to 2x minus 3. Now look at this one. That's a constant. I mean independent of x. And this is 2 minus x. So 2 minus x is again is a straight line, but it's a decreasing one. Because as x increases, the value for 2 minus x decreases. It's a decreasing one. Okay. Now see, we have a minima at x is equal to 2. Okay, now what are the possibilities? So there are 3 possibilities here. Either the line will be something like this, or it could be like this, or it could be something like this. Now think and tell me that in which of these 3 cases we won't have minima at x is equal to 2. We will not have minima at x is equal to 2 only and only when the line is something in this form. Okay, why? Because in that case the value at x is equal to is this, and on the left side the value is smaller than the value of the function at 2, so it can't be minima. So that means, so what's so special in that line? The special thing in that line is that the line shouldn't be below, I mean the point where it is approaching the line x is equal to 2 should not be below this value, and which is 1 here. Okay, so that's 1 here. What does that mean? Put x is equal to 2 here in 2 minus x plus whatever it is, a square minus 9a minus 9, which is f of x. So as x approaches 2, okay, so the value to which it approaches will be 2 minus 2. Okay, so a square minus 9a minus 9, that value should be greater than or equal to 1, and that's it. I think all of you would have understood. Okay, so either any line which matches here with this point or above it, because in that case this is always going to be the point of minima. So that's it. So solve it. So a square minus 9a minus 10 is greater than equal to 0. So a minus 10 into a plus 1 greater than equal to 0. Open upward quadratic positive beyond the root. So that means a should be greater than equal to 10 or a less than equal to minus 1. Now see, we are given for positive integral constant. So that's not possible. So that's it. And the minimum value here is 10. So a, the minimum integral value of a should be 10 here. Then the least integral value of a should be 10 here. And that's it. Okay, so now moving to the last question of the test paper, the number of values of k, where k is a natural number for which the system of equation k minus 1 times x plus 3k plus 1 times y plus 2kz equal to 0. It's k minus 1 times x plus 4k minus 2 times y plus k plus 3 times z equal to 0, and then 2x plus 3k plus 1 times y plus 3 times k minus 1 times z equal to 0 has a common non-zero solution. See, that's a homogeneous system of linear equation, and we know that homogeneous system always has a solution which we call a trivial solution. And what is it? So that's 0, 0, 0 origin. Okay, we call it trivial because it's pretty obvious. We don't have to solve to get the solution. We know there's no constant for any curve, for any polynomial form of the curve. If there's no constant, that will always pass through the origin. So all the three equations satisfy 0, 0, 0. That's the trivial solution. Now, if we have a non-zero solution, what does that mean? That means we have infinite solution. See, I believe you all know that for a system of equations, you can't have a possibility of having two solutions or three solutions. So the possibilities are just three. No solution, which is not possible here because that's always a solution. Or unique solution, that means 0, 0, 0 is the only solution, or infinite solution. Or if we have an extra non-zero solution, that means we have infinite solution. So what are the conditions? So here delta should be equal to 0 because, see, again I am repeating, because there is no possibility of no solution here. So delta equal to 0 means infinite solution, and delta not equal to 0 means unique solution, which is the trivial solution. So if you have non-trivial solution for a system of homogeneous equation, that means delta has to be 0. So just use this, you know what is delta. So coefficient of x form the first column of determinant, coefficient of y form second column, coefficient of z form the third column. You just need to solve it. Might be a bit lengthy, but then that's what we will be doing. So solve it, you get some relations over k, and from there you can judge how many values of k are we going to get. So that's it. So with that we end our solution of this paper 1. Paper 2 is going to be particularly for those students. Of course, I will suggest to all of you to attempt that paper. Okay, 75 minutes and then 25 questions. But particularly that is going to be an easy paper for those students who are going to take their examination on 22nd or 23rd of Jan, bachon. Okay, so next one is going to be a bit easier one, keeping in mind the first initial few shifts of the JEE mains. Okay, chaliye, with all the best wishes from our side, from our channel side, to all of you bachon, work hard. Keep your focus, keep revising the things, and only I will say, don't take up any new questions from any source. If you are solving test paper, that's it. Otherwise, don't solve any new questions from now onwards. Okay, so that's it. Chaliye, we'll meet in the next video with the solution of the next paper, bachon.